In this video, I would like to summarize many different ways to debug a deep learning development pipeline. A good place to start is here. That is, the first step is to train using the training set and evaluate on the training set itself. Yes, I'm not saying validation set, but the training set itself. So after you've splitted the data into maybe training set, and a validation set and test set, we first take the training set and evaluate on the training set. If the error is not very high, if the error is good, you're getting really good accuracies and you're doing really well, then thumbs up. The next step is to train using the training set and evaluate on the validation set. But if you're getting high error, even on the training set itself, then here are the debugging tips. The first thing you want to check is if there are any non-numerical values in your data. It is possible that maybe many of the values are zeros, or you want to look at the distribution of the values in your data. Distribution. Maybe your columns or your inputs. You also want to check if your loss function is appropriate. Are you using, say, for example, binary cross entropy for binary classification? Is your last layer activation appropriate? For example, for binary classification, you want to use sigmoid, right? For positive output, you may want to use ReLU as your last layer activation. Have you tried normalizing your input? If it is images, maybe dividing by 255. If it is data, use something like normalization, the standardization techniques to normalize the data. The next debugging technique is to plot the learning curve and see how the training accuracy, training loss is going down or not as you train. The next technique is to try only with a few data samples. So you may have 1,000 rows of data or 1,000 images that you're working with. Take it out and just take 10 of them and see if you can improve, if the model does better on that, and then go from there. And then if that still doesn't work, try only one example or just a few input features. So here, not examples, but actually input features. So here, if you have tabular data, then you may want to cut out all the columns and only maybe keep 2 or 3 important columns as input. You also want to check, does your model have too many layers? Decrease the number of layers and see if that helps. Sometimes your output labels may be too large in range. Do those need to be normalized? You may want to consider that. Also, you want to check what values your model is generating. So as you train the model, when it makes predictions, what values is it predicting? Is it predicting everything 0? Is it predicting everything 1? What exactly is it predicting? So checking that may give you some pointers on what's happening. And you also want to check and make sure that your loss is decreasing over epoch. So if you look at the learning curve, then in the learning curve, the loss should be decreasing over epochs. If the loss is constant, then that also signals that something is wrong. One of the really powerful ways to debug is to add the output labels as one of the input features. So feed the output as the input and the model should immediately work. If it doesn't, there's something fundamentally wrong in terms of basic logic in your overall pipeline. Try training bigger models, more neurons and more layers. That might work. And train longer, much more epochs, maybe a few hundred or a few thousand epochs to see if that helps. And then if none of those work, then that means you may be using the wrong architecture for your data set. So try a completely new model architecture. So assuming that these debugging tips help and eventually you get very low error on the training set, the next step is to train using the training set and evaluate on the validation set. So now here, if you get very high error, then further we have to debug. So if the error is high, you're unhappy and we want to debug further. But if the error is low, that is you're getting very good accuracy on the validation set, then you're happy. Then finally what you want to do is train using the dev set, that is the entire training and the validation set, and evaluate on the test set. That will be the next step. So let's go back and look at the techniques to debug when your training accuracy is good, but the validation accuracy isn't really good. The first technique is to get more data. When I say more real data if you can. If you don't have very easy ways to get more data, then you want to try techniques of regularization, that is maybe L1 norm, L2 norm, etc. And you also want to try new model architectures to see if the architecture that you are using is not the correct architecture. You also want to check if your data is shuffled or not. Now, talking about the regularization techniques, here are some techniques to regularize your model. So the first technique is data augmentation. That is, we bring in more fake data from the existing data. The next technique is to reduce the network's size. And also try weight regularization like L1 and L2 regularization. The other technique is to add dropout layers. We also want to make sure we are using orderly stopping and checkpointing. And also the last tip would be to add batch norm layers to regularize the model. So these regularization techniques should eventually help you to get low error on the training set and eventually get high accuracy. Now, say when we evaluate on the test set, right, and then we get very high error, what do? Once again, we do the same thing that we did when we had high error on the validation set. So you want to keep repeating this until you get very high accuracy on the validation set, and then finally evaluate on the test set.